let's try this example with something that would be a bit trickier for a compiler to know in advance. Let's just say um, if a value is 1, 2, 3, 4, 5, and the value is not 1, 2, 3, 4, 5, maybe it's 5, 4, 3, 2, 1, a different value, then could say scanner equals new. Else we could say scanner equals null, something like that. Null, of course, is a reference to no object. Basically, null is specifying an object with like address 0, which signals the rest of the program that there is no such object. Null keyword exists in Java and in other programming languages specifically for the purpose of specifying an object reference which not pointing to any real object for a while or for whatever reason. So in this case, my value is 5, 4, 3, 2, 1. This if statement will not work, so this will never happen. I never create the scanner, and so I will just keep the scanner equal null. I will run this example, and then my program crashes. I say enter an integer. The next thing that happens is that it says exception in thread main, language null pointer exception, and this took place in main.java line 18. So if you click on this, this is the line 18 that has failed. So the scanner remained null, and I got this null pointer exception. One possibility would be to say, try, and then, try all of this, and then catch null, would just copy and paste because I'm lazy, right? So I'm just going to say catch this null pointer exception right here, ex, and do something, for instance. For instance, what I could do is that I could print another message that says input stream is not, or say does not exist. There's no input stream exists to take input from. Let's try something like this. So enter an integer, input stream does not exist, and we exit. Okay? Because, we try to anticipate this null pointer exception. But many programmers would also choose perhaps a different approach to this particular exception. I will just get rid of this try and catch for a second. And instead, what I'm going to use is that I'm going to perhaps bring this back and say something like this. If scanner sc is not null, you can use equal or not equal comparison with using object references with the null keyword to find out if they're actually referring to some real objects in memory. So another if statement, and I will arrange it more or less nicely. So if not now, then okay, go next and so forth. Otherwise, otherwise, I will say no, the input does not exist. So perhaps this is a more popular approach with programmers to check for possibilities of null. And it's perhaps faster too, because uh, the mechanisms that generate exceptions are somewhat expensive because real exception objects are instantiated. We talked on Tuesday that the program stack has to propagate those exception objects to the exception handlers, and eventually the catch block, there could be multiple catch blocks, and the appropriate catch block finally is found and is given the exception to process to handle the error. Whereas this if statement is very kind of neat and it makes sense to use. Hopefully that makes sense, that checking references for nulls is better choice than say try and catch and proceed with all this exception business. So that's one case where you probably don't want to use exceptions, but rely on something like this. And let me make it even easier on the eye by doing the following. How about this? I can simplify it further by combining those two uh, condition that the scanner is not null and scanner also has the next int into one condition. So I can say if scanner is not null and at the same time, this is logical AND operator, and at the same time the scanner has next int, and obviously I need to form the proper exception, that the proper condition, so that everything is wrapped in the matching set of parentheses. So then I can say value next int, otherwise no integer available to input. Well, what I could say here, not to mislead the user, that failed to input a value, something like that. This is an interesting case worth considering. So let's try this. So in my case, the scanner will be null because I'm still doing this and I'm keeping it null for the purpose of demonstration that, yeah, there could be possibility for creating a scanner, but in my case, it's just going to remain null. So run it. So it says, failed to input a value, and the program didn't crash. The explanation for this behavior is that this particular condition right here contains two parts. Part 1, which returns true or false, and part 2, which also returns true or false. And we're saying only when both of these parts together are true, then we're going to execute this code, and hopefully we will not crash. But how come is that the scanner is null, but then at the same time, scanner has next did not cause a problem? It's because the logical AND operator short circuits. It says, all right, let me take a look at this condition. Is it true or false? Oh, it's false. When guess what? If this is false, then there's no other possible values that could make this entire condition true. Because whether or not has next returns true or false, or whatever else it does, there will be absolutely no way that this if statement condition returns true, because it already returned false in its first part. So this is never executed. It's really never executed. It's simply ignored and the execution moves on. In our case, we just exit out of this program. So that's a good behavior of short circuiting in our case. so that we can write very efficient code, and I would argue it's also pretty readable. So the readability of this code is good. In some other cases, you may want this always to execute, and then you're in trouble, because there could be some condition here which not specifically refers to a check for a null, but something else, and you would also always want this to run, and then short circuiting could hurt you, because you need to be aware of it, that if this part is false, the second part, regardless to what it does, whether you want it to execute or not, whether you want it to evaluate to true or false, it will never execute. To combat that, if again, let me change this to 1, 2, 3, 4, 5, maybe, to create a real scanner. If you do want this always to execute, what you do is this. You sort of say, Boolean I'll say is good input available. Kind of ugly name, but since it's not exactly instantly obvious why this flag is here, I created this ugly name so that it could be used here. This case, of course, because I always wanted this to execute, and I'm noticing that my logic uses the short circuiting, because that's the behavior of the logical AND operator. Well, you know what? I took my method out, made sure that it executes, got the result, and then used the result in the condition. So I split some execution out of this condition and put it before the condition.